Okay, Assalamu alaikum wa rahmatullahi wa barakatuhu. So I will now continue with where we left. Okay, the last thing we were discussing was that table 4.3 on page 104, right? Now, before I start electrolysis, one uh, there was one point that I forgot to mention, that I had gotten a slide for you guys. I got a slide for you guys to show. I showed you the ionic crystal lattice where the ions were tightly bonded to each other, and so there were no free ions for conduction. Now I want to show you the covalent giant structure. This is a structure of diamond. Diamond, if you know, is pure carbon, meaning carbon covalently bonded to 4 other carbon atoms. So all these white balls that you can see here, they are all carbon atoms, and they are covalently bonded to 4 other carbon atoms. Okay, so you can see that all the valence electrons, by valence electrons I mean electrons in the outermost shell of an atom, are involved in the bond formation. So there are no free ions available for conduction. Therefore, diamond is an insulator. It cannot conduct. So I told you, of the solids, only metals conduct, and of the non-metal solids, only graphite can conduct. Okay, we have semiconductors, but I'm not going to confuse you with talking about them right now. That you might do later. Okay, so this is diamond, this is a covalent. Now, how many types of covalent substances do we have? How many types of covalent substances do we have? One is this giant. I'm giving you one is this giant diamond. Okay, is there any other that you can think of? Covalent. You can use the chat window. You can use the chat window if you know the answer. One giant, the other small. Small, what do you mean small? Simple covalent structures like what, Hania? Yes, you are right. Yes, I am waiting for the keyword. What do you mean simple covalent what? Simple covalent what? One is the giant lattice, right? Which is diamond. Graphite is also an example of giant lattice. No, beta, covalent simple molecules. Molecules such as carbon dioxide. Yes, Hania, yes, molecules such as carbon dioxide. Now in carbon dioxide, carbon, oxygen, both of them are non-metal. So they are not charged particles, they are simple molecules. For example, water. Yes, good job, Amna. Good job. Yes, water is an example. Oxygen example. All the halogen diatomic molecules, they are examples. Non-metals, covalent, and therefore uncharged simple molecules. So we have 2 types of covalent. Yes, carbon dioxide, good job. Oxygen, good job. Yes. So these are all simple covalent molecules. So you guys were answering me, you guys knew it, but you were not using the key word that I was looking for, and that was the word molecule. Molecule was the key word. So there are 2 types of covalent. One is molecule, the other is giant, right? Both of them cannot conduct electricity except for graphite, which is an exception. Okay, then I would like you to pay attention to the differences they have mentioned between metallic and electrolytic conductivity on page 105. On page 105, this metallic conductivity and electrolytic conductivity. In metallic conductivity, electrons flow. Okay, examples are metals and graphite and alloys. You know what alloys are? Metallic mixtures. Okay, when you mix 2 metals together. It takes place in solids and liquids. Why have they mentioned liquids and metallic conductivity? And can anybody answer this question? Why did they say metallic conductivity takes place in solids? Solids we understand, metals and graphite. Why liquids? Which liquid can you think of which has metallic conductivity? Yes, Ibrahim, molten. Molten form of what? Yes, molten what? Molten what? You guys give me a half answers. Yes, Hania, good job. Molten metal, yes. Can you think of a very common example of a molten metal that that is liquid at room temperature? Liquid at room temperature. Yes, Ibrahim, mercury. Yes, mercury. In thermometers, yes, mercury is a metal which is liquid at room temperature, and therefore it can conduct electricity even at room temperature. Yes, good job. So what other points have they talked about? No chemical change takes place when there is metallic conductivity through solids, but electrolytic is through liquids, through electrolytes. Electrolytes are those liquids that can conduct electricity. So ions are like no electrons, okay? No electrons in case of liquids. So ions or charged particles, flow, mobile, okay? Mobile charged particles, property of ionic compounds. Because ions come from ionic compounds, right? So can be either in the form of molten liquid or dissolved aqueous solution. Takes place in liquids and solutions, but not solids. Chemical decomposition takes place. So when electricity passes through liquids, it decomposes it into its simpler components, so that so therefore it's a chemical change, right? These points should be clear to you guys. And then these were the lists of electrolytes: molten, salts, okay, solutions of salts in water, solutions of acids, and solutions of alkalis, okay? By the way, molten mercury or molten metal will have metallic conductivity, and therefore it won't be included as it won't be included as electrolyte. It cannot be classified as an electrolyte, okay? Molten mercury will not be an electrolyte, because if you look at the definition of electrolyte, it is a liquid that can conduct electricity by the movement of ions, okay? And we don't have ions in molten mercury, but we have free electrons, mobile electrons, which are responsible for conduction in molten mercury because it's a molten metal. Now, is there any question? Should I move on? Okay, let's move on. If there is any question, write it down in the chat window. I will check. Okay, I get a notification and then I can check the chat window and then I will address to your question. The reason why I am not unmuting you, giving you a chance, is because, you know, that takes a lot of time, and then we have only 1 hour, right? And I would try to at least finish electrolysis of molten compounds, if not more. Okay, now I made this diagram of an ionic compound, molten zinc chloride, right? Now, since this is simple ionic compound in the molten state, okay, there are only 2 ions that come out of it, okay? It's made up of 2 ions, zinc ion and chloride ions, right? I have shown only 2 for simplicity, to keep things simple. Now, whenever you write an overall equation for first of all, let me explain you the apparatus, the setup. You have this is called an electrolytic cell. Okay, electrolytic cell is just a setup of apparatus where electrolysis takes place. Now, this is a container containing this molten ionic compound, which is zinc chloride, and we have these 2 electrodes. Now, what is the most preferable substance for electrodes and why? What is the most, this is a question for you guys. What is the most suitable? Yes, carbon in the form of, in which form? Carbon in the form of? No, carbon in the, yes, Hania, good job. Graphite, yes. Carbon, yes. Aisha Nadeem, yes. Graphite. Why is graphite the most preferable electrode for electrolysis? Real quick, real quick. Come on, guys. Yes, it's economical. It's cheap. Very good, Hania. Another. It's inert. Yes, Hala. Yes. So these are the 2 points. Okay, these are the two advantages of using graphite in electrolysis. Yes, unreactive, inert, unreactive. Yes, you can use either term. So graphite is inert. It will not react with the electrolytes. It will not react with the ions involved, and therefore will not disturb our results. And secondly, it is cheap as well. Just take out a lid out of a pencil and it will work as your electrode. Okay, so graphite are the electrodes which we have used, and these should be copper wires because this is an electrical circuit. The shorter line represents the negative terminal of the battery. The longer line represents the positive terminal of the battery. Yes, Ibrahim, yes, and copper conducts well too. So we have these two ions, and we know they will not react with this carbon in the graphite electrode. So, okay. Now, because this electrode is connected to the negative terminal of the battery, and negative terminal of the battery, remember, was that part where the electrons were all squeezed up. Remember, yesterday we were talking about it. So this has an excess of electrons. This has an excess of electrons on it. Okay, therefore this electrode has a net negative charge. Okay, but because the electrons are moving away this way, this is relatively devoid of electrons, or it has lesser electrons, which makes this terminal positive. Okay, so there are no electrons here. Okay, now zinc, because of its, and okay, now yesterday I also explained you how by looking at a compound you can make out if it is ionic or not, right? The anion should be non-metal. The cation should be from a metal. Remember that metalloid staircase? Yeah. So this chlorine is from a non-metal, and the zinc is a transition metal. So together we have this ionic compound. So we know it's ionic, so it must give ions, right? Now, once you know the ions that it has, you should know how these ions exist in their natural form. How does zinc exist in its natural form on its own? In the form of metallic solid, because it's a metal. Metals usually exist in the form of metallic solid at room temperature. Whereas chlorine exists as a gas. Okay, we know that already. You should know that. Okay, how the elements exist in nature. Okay, which ones are gases, which one are solids, and which ones are liquids. Okay, so this is molten, that's why I've written liquid. Even if it is not molten, we gotta melt it. And if you melt an ionic compound, you will require a lot of heat to 1000 degrees Celsius maybe, because the ionic bond is too strong. In order to melt, in order to break these ionic bonds, you have to provide a lot of energy and bring the temperature to around 1000, right? Now, we know we will get zinc solid. So basically, this electrolyte will decompose into its components in their natural state. The components will be deposited in their natural state. So here you will see deposition of zinc. Okay, and I think zinc in the solid form is white in color. Whereas near the cathode, you will see chlorine gas. Now, how will you observe chlorine gas? You should know how chlorine gas looks like in reality. Yeah, it's a yellowish greenish gas. So you should expect a yellowish greenish gas here, and we can have a test tube here to collect it. We can have a test tube here to collect it if we want, and you will see zinc deposition on the electrode. So you should know how, first of all, you should know if the electrolyte you're using is ionic or not. Okay, yes, these experiments need caution. Okay, and especially if you have some poisonous gas being released in an experiment, you have to be extra careful. That should be carried out in a fume cupboard. Fume cupboard collects the fumes and does not allow it from affecting us. Okay, and we should also be wearing goggles and masks and all of those safety precautions. Okay, so yeah, first of all, you should know if the compound is ionic, and then you should know what ions and the charges on them. Okay, and then what is the natural state of the components with which that compound is made up of. So you will have an overall reaction. Okay, that's how you will have the overall reaction. Now, of course, the cations will be attracted towards the negatively charged electrode, which is the cathode, right? And because of the opposite electrostatic attraction between the opposite charges. Now, when the cation gets attracted towards the cathode, it accepts two electrons. It accepts two electrons, and when it was devoid of two electrons initially, right? So when it accepted two electrons, it neutralized into solid, and that's how it is deposited in the solid. So for the cathode reaction, you know cathode is negatively charged, or you can remember it like cathode, so cations. Cathodes, cations will be attracted towards it. And by the way, this electrode is named cathode because it attracts cations. So cathode for cations, right? And cations will accept electrons to be reduced into zinc solid, because this is gain of electrons, so this is reduction. So we have reduction taking place at cathode. Okay, whereas at anode, because anode is positively charged, it will attract negatively charged anions towards it. Okay, and anions, when will get attracted towards this positively charged anode, they will lose their extra electrons, because this electrode was devoid of any electrons. So they lose electrons here. Electrons are lost. And loss of electron is oxidation. Okay, so oxidation takes place at the anode. Anode, and for anions. Okay, and for anions, it attracts anions towards it. Now you have the cathode reaction, you have the anode reaction. Make sure that your electrons gained and electrons lost are equal. If electrons lost and electrons gained are not equal, you have to adjust accordingly. Okay, you cannot cut anything, but you will have to multiply the whole equation by the number that will give you equal number of electrons at both the reactions or both the equations. Okay, then two electrons and two electrons get cancelled. Okay, and then we will write these two equations together, like we will like kind of add the two equations. So zinc ions in the liquid form, 2 chloride in the liquid form, giving us zinc solid and chlorine gas. Now you should make sure that your equation is balanced. Okay, here again, chlorine exists in a diatomic form. So it has to be chlorine, Cl2. For that, you need 2 atoms. 2 atoms will come from 2 chloride ions. 2 chloride ions. So that's why you have 2 coefficient with chloride, and then this is the chlorine gas. Okay, this is simple electrolysis of molten compounds. Now, I have made this list of elements which are diatomic. Okay, I got this from Google. I liked it. And remember, I also recommended Tyler DeWitt's videos on YouTube. They are extremely, extremely helpful. Okay, so these are diatomic elements. Okay, so you have all these are halogens except for hydrogen, nitrogen, and oxygen. All these are halogens except for hydrogen, nitrogen, and oxygen. And you will also find mnemonics there if you want to learn them. You know, knowing which elements are diatomic helps. Okay, you know that they exist in a diatomic form, so you can balance your equation accordingly. Now, let's write the cathode and anode reactions for the electrolysis of these ionic compounds. Okay, Let's take copper bromide. It looks a little complicated. Let's just start with copper bromide. Okay, I took this from your book. Okay, now copper bromide. First of all, we should know its formula. How did I write this formula? Copper has an oxidation, and by the way, it says here, it mentions that it is copper 2 bromide. It says here copper 2 bromide. Okay, so this 2 would come here. Maybe I shouldn't, I don't, okay. So oxidation state of +2, and bromine has an oxidation state of -1 because this is a halogen, right? So 1 comes here, 2 comes here. We don't write 1. So I won't write 1. So that's how I got this formula. I hope you guys by now know how to write formula, right? You're in grade 8. So I expect that you know how to write formulae. If you do not know, then let me know. Then I can do a class on how to write formulae and how to balance equations. Okay, so copper bromide will split into, in electrolysis, it will split into in its components, right? Copper plus bromine, and bromine exists diatomic. Okay, it is a diatomic molecule, and copper is metal, so it exists on its own. Okay, this is solid. Josema, please pay attention to what I'm teaching. Okay, don't worry about how I'm holding my cell phone. Okay, I have help, alhamdulillah. Okay, my daughter is helping me. Okay, so copper bromide breaks down into its components, copper and bromine. Bromine exists as a gas, vapors, right? Now, cathode reaction and anode reaction. Cathode reaction. Now, cathode has to deal with cations, right? Cations. So, copper 2+, because it is in the form of ions here. This is an ionic compound, is it? This is halogen, this is transition. Metal, non-metal, ionic compound. I know that. Okay, copper 2+ will accept 2 electrons. Oh, I'm sorry, I forgot to write 2 electrons here. I should have written 2 electrons here. Yes, 2 electrons accepted, copper solid. This is my cathode reaction, right? Okay, now anode reaction. This is easy. Bromide, because it is in the ionic form. So I will write the ion. I started with the ions first. And then it accepted, oh sorry, it lost. It lost 2 electrons. Why 2 electrons? Because it is in the diatomic form. It is released in the diatomic form. So each atom lost 1 electron, so total of 2 electrons. Okay, so if this is 2, there should be 2 here. Okay, in order to balance, I just balanced. Okay, so you should have the same charge on both the sides. 2 minus, 2 minus. So electrically balanced, chemically balanced. Here, 2 plus 2 minus, total 0, 0. 2 plus 2 minus 0, 0. So this is electrically and chemically balanced. Do I have 2 electrons on both the equations? Yes. So 2 electrons got cancelled. Now I will add, the overall reaction would be, I will add the 2 up and I will copper 2+ plus 2 bromide, giving me copper plus bromine. And I will write down their state symbols, liquid, because this was molten liquid, so liquid, and solid, and this is gas. Okay, this is how I got the overall reaction. Okay, now I have a question. Who will answer this question? Josema, you will answer. Okay, you will answer this question. Tell me, what type of reaction is this? What type of reaction is this? Kozama will answer me. Where is he? Yes. Kozama? Yes, बेटा क्या हुआ, डर गए आप? अब मुझे आंसर नहीं कर रहे. You don't know? Okay. Who else? Okay, Aisha Nadeem. Yes. Yes, Aisha?
Decomposition.
Decomposition? You called it decomposition because you saw one reactant on the left side and then two products on the right side. Well, yeah, I won't blame you. It is looking like decomposition, but pay attention. Look closely. Ionization? Okay. Write down all your answers here. Ionic reaction, redox. Okay. मैं एक बात बताऊं, जो ये आंसर करेगा ना, मैं उसको मान जाऊंगी. Like he is the real chemist here. Okay, Aisha Zahid, yes? Yes, Aisha Zahid?
Ma'am, I think it's a redox reaction.
How come?
And
can you please explain a little? What is getting oxidized and what is getting reduced? Tell me. What is getting oxidized and what is getting reduced? Electrolysis reaction.
In
Okay, let me ask from others. Let me give chance to others. Amina, you still want to answer? Thermal decomposition? No. Chloride is oxidizing. Chlorine is oxidizing. Okay, those people who are saying it is a redox reaction. Arham, what do you want to say? Anu. Okay, yes. Anu, I've unmuted you.
It's a synthesis reaction.
Huh? Synthesis?
No.
No, you're not sure? I have tricked you guys so bad. Amna, you, last chance. Yes, Amna. Explain me how. You know, when you will explain your answer, you will get to the right answer.
Because calcium chloride.
Okay, ionization.
Because potassium chloride is being broken down into its ions, potassium and chlorine.
Potassium and chlorine?
Chloride.
Look harder, it's not, it's chloride. Yeah, I wanted to address this. Potassium is being reduced and chlorine is being oxidized. Aisha Zahid. Okay. Potassium, what did you say? Potassium is being oxidized. Okay. Who said this? Redox. Okay, those people who are saying redox, ionization because it's splitting into ions, electrolysis reaction, that's no reaction. Who said that? Galaxy A7. That's no reaction, Galaxy A7. Galaxy A7, who is this? Yes, Galaxy A7. I'm unmuting you. Please explain your answer. I'm unmuting you, but you're not getting mute. Oh, sorry, you're not getting, yes. Okay, Galaxy A7, can you please explain your answer? Hello, Galaxy A7. Your answer is correct. Please explain. He just said it, and I think he's getting shy. He doesn't want to answer. Yes, Amana? Yes, you want to say something?
No.
No. Okay. Let me explain it. Okay. This is no reaction. This is no reaction. You know why? Because it's the same thing. I just wrote them separately. Same thing. This is what? This is an ionic compound. Okay, this is ionic compound. It is in the form of potassium ions and chloride ions. It is just because I wrote it separately. I mean, do you think they will exist on their own? No, together in the molten form, liquid potassium ions, chloride ions. Because if you visualize them in a container, if you have melted it, or even if you have dissolved it, molten or dissolved, they will be in the form of potassium ions and chloride ions. That's it. I have just written it in separately. Now, those people who were saying that this is redox reaction, okay, you should have looked at it a little closer. Okay, a little closer. Look at this. What is the oxidation state of potassium here? What is the oxidation state of potassium here? Do you think it's 0? No, it is bound to another element. It is in the form of compound. It's +1. And what is the oxidation state of chloride? It is -1. So nothing is happening. It is +1 here as well. This is -1 here as well. Nothing happened. Sorry. Nothing happened. I have just written them in separate form. Nothing happened. This is already ionized. This is already ionized. The only thing is I wrote it together. That's all. That's all I did, and you guys got confused. Okay, so this is how they confuse you. Okay, so you have to appreciate the fact that as long as this is ionic and as long as they are in the liquid form, if this was solid, then that would be that you can say that, you know, they are bonded together. But even in the solid form, there's potassium ion is still potassium ion, chloride ion is still chloride ion. So this is no reaction. Okay, same thing. Potassium chloride ions. I just wrote them separately. Okay, so don't get confused in that way. Now, another question for you guys. We use electrolysis for the extraction of very reactive metals, right? Why don't we use extraction? Why don't we use electrolysis for the extraction of less reactive metals? Yes. Why don't we use electrolysis for the less reactive reactions? No, Saad Amir, no. This type of question cannot be in the exam, but you should know it. Sometimes they do confuse you. They give you options. They give you ridiculous options, and you should be able to recognize them. Yeah. They can be, yes, very good, Hala. The less reactive metals can be extracted by displacement by which element? By which element can be displaced by which element? Less reactive metals can be extracted by which element? Hey, you guys forgot your grade 6, 7 chemistry? Remember we did extraction of less reactive metals in grade 6 and 7? Yes, Atika? Yes?
By carbon?
Good job. Yes, reduction by carbon. Yes. So look at this reactivity series. This reactivity series I made for you. Why don't I get this? Okay. Yes, this is the reactivity series. So metals which are above carbon, they cannot be reduced by carbon, because in reduction, carbon has to displace one of these. Now, carbon can displace only the metals which are lesser reactive than carbon. Okay, so for these metals, we use electrolysis. We use electrolysis for those metals which are above carbon in the reactivity series. For the rest of the metals, we can reduce them by carbon. Okay, so their extraction is by reduction by carbon. reduction by carbon. Okay, remember, if you remember, you did this in grade 6 and 7. I don't remember, but yeah, maybe in grade 7. Extraction of less reactive metals can be done by reduction by carbon. Like iron exists in the form of iron oxide. We were using carbon monoxide as the reducing agent because it is reducing. Yes, this is reduction as well as displacement. Here, this particular equation is just reduction. Okay, this is just reduction. Okay, displacement is when you have single reactant. One of the reactants should be single. When both of them are compounds, then it is difficult to say whether it is displacement. Okay, or yeah, you cannot say if this is displacement single or double. Yeah, I can see that the iron has been kicked out, but still. Okay, so keep yourself safe and just confine yourself to the answer redox. This is a redox reaction. Okay, and this is redox as well as displacement. Can you see the elements have switched partners? Oxygen is now with carbon, so this is single displacement. This is single displacement as well as redox. So carbon has kicked out zinc. So carbon has reduced zinc and bonded with oxygen to form carbon monoxide. Okay, here the oxidation state of zinc is +2. Here it is 0. Okay, so from +2 to 0 is reduction. Here the oxidation state of carbon is 0, and here it is +2. Yes, Amina, good job. Yes. Okay, that's the mnemonic for the reactivity series. Okay, so have I covered everything? Galaxy A7 said that this reaction is no reaction, which is the correct answer, but he did not explain me why. So maybe it was just a tukka. I don't know. You have to give me the reasons behind your answers, otherwise I won't be convinced. Maybe you read it from somewhere, but you don't know the real reason behind it, then yeah. Okay, so okay, now let's move on to the industrial extraction of aluminum. Industrial extraction of aluminum. Okay, let me share my screen with you. I showed you all these slides, right, yesterday. I just want to double check if I'm missing any. Everybody knows how the ions dissolve, right? Let's try these questions before we move on to the industrial electrolysis of aluminum. These questions are regarding conductivity. Okay, which statement about conduction of electricity is correct? Electricity is conducted in aqueous solution by electrons. Electricity is conducted in a metal wire by ions. Electricity is conducted in a molten electrolyte by electrons. Electricity is conducted in an acid solution by ions. Who will answer this question? Who will answer this question? Option C. Yes, Hala, good job. Good job. It is D. It is D. The conduction of electricity in an acid solution is by ions. See, in the option A is wrong. Why? Now let's discuss why the rest of the 3 options are wrong. Electricity is conducted in aqueous solutions by electrons? No. Electrons are only found in metals. Electrons which are available for conduction are only found in metals or graphite. Remember, we discussed not in aqueous solution. Yes, in aqueous solution, you have ions from the crystal, and you have water's own ions, hydrogen and hydroxide ions. Okay. Now, electricity is conducted in the metal wire by ions. No, in the wire, metal wire, metal. Metal has mobile electrons, not ions. Ions are in solutions or electrolyte. Electricity is conducted in a molten electrolyte by electrons? No, again, electrons are only in either metal or graphite. Okay, and electrolytes have ions. Okay, I hope everybody is clear on this. Then this question, an electrical circuit is set up using copper wire. Which process takes place in the copper wire? In the copper wire. Now remember, copper is a metal, so it should have mobile electrons for conduction. Now, option A, electrons move along the wire to the negative terminal. Positive ions stay in position. No way. There are no positive ions and electrons are not moving to the negative terminal. Option B, electrons move along the wire to the positive terminal. Well, yes. Positive ions move to the negative terminal. No, there are no ions. So the first part is correct, but the latter part is incorrect. C, electrons move along the wire to the positive terminal. Yes. Positive ions stay in position. There are no positive ions. Okay, D, negative ions move along the wire to the positive terminal. Wait. Oh, okay. Now I got it. Positive ions meaning those, okay, positive ions, by positive ions, they mean to say those cations which are embedded in the sea of free electrons. Remember the metallic structure I showed you? Wait, let me show you back. The metal, this one, this. By positive ions, they mean to say these cations which are embedded in the sea of electrons. They're talking about them. Well, they will be fixed in their positions. They won't move. They might vibrate, like as they are vibrating here, but they won't move. It is the free electrons that will move. Okay, so let me see. Okay, so now let me, okay, so electrons move along the wire to the negative terminal and positive ions stay in position. No, that is wrong. Electrons move along the wire to the positive terminal. Yes, positive ions move. No. And then option C. It is option C. Electrons move along the wire to the positive terminal and positive ions stay in position. So it is C. Okay. Then 10. Why does molten sodium chloride conduct electricity? Now we know molten sodium, before I even read the options, I know that sodium chloride, molten sodium chloride has mobile ions, no electrons. So we're not going to talk about electrons here. An electron is completely transferred from sodium to chlorine. Okay. B, sodium ions are only weakly attracted to the chloride ions. No, they are very strongly attracted. The electrons in the sodium chloride are free to move? No way. No, they're not free to move. Molten. No, but not the electrons. They are the ions which are free to move, not electrons. The sodium ions and the chloride ions are free to move. Yes. D. D is the correct option. Okay, D is responsible. Sodium ions and the chloride ions are free to move. Okay, next question. A substance Q conducts electricity both when solid and molten. Substance Q conducts electricity both when solid and molten. What is Q? So if both solid and molten, must be a metal. Must be a metal. An alloy, a hydrocarbon, a metal oxide, a salt. So metal, that means alloy. I hope all of you know alloy. Alloy is a mixture of two metals. So two metals, two different types of metals are melted and then they are mixed together. Okay, hydrocarbon is a covalent molecule, so cannot conduct electricity. Metal oxide is an ionic compound, ionic crystal, cannot conduct electricity when solid. Salt, again ionic, cannot conduct electricity in solid. Okay, 19. All of the following substances can conduct electricity. Which substance's conductivity is not due to the movement of electrons? Not due to the movement of electrons. Aluminum. Well, it has free electrons. Graphite. Graphite has free electrons. Lithium chloride. Okay. Mercury. Mercury is also a metal. It has free electrons. So yes, it is lithium chloride. because lithium chloride in the molten state will conduct electricity due to mobile ions, not electrons. Okay, so C is the answer. Okay. Do you want to do more questions, or let me get back to your book? Wow, you guys have given answers. Good job. Good job. From where you got these questions? More questions, questions. Wow, Jiva. Okay, let me just finish your book real quick, okay, because we have 15 minutes left. Okay. Let's talk about these movement of ions on your page 105. Okay, electrolysis of copper to chromate 6. Copper to chromate 6. Okay, now what's happening here in copper to chromate 6? Let me, can you please hold this? Okay, copper to chromate 6. Now, how do I write this formula? This is a really complicated compound, huh? Now, copper is the cation in this, okay? And then because the name, you know, keep your eyes on page 105, the bottom line. For example, copper to chromate 6, okay? Copper 2 meaning that copper has the oxidation state of 2+ in this particular compound. And then chromate. Chromate, I told you, I don't know if I have told you this before or not, 8, the suffix 8 you have at the end of a formula name when you have oxygen in the anion. When you have oxygen in the anion, right? Now, chromate has a charge of 2-. The reason why they have written 6 is because the oxidation state of chromium in chromate is +6. Okay, I hope you're getting me. By the way, I was thinking that I will take one class on how to calculate the oxidation state of elements in different compounds. That's very important to know. So the oxidation state of chromium here is +6. So copper 2+ and chromium is 6. Remember, in this compound, we have 2 transition metals. One is copper, the other is chromium. By the way, I told you chromium means color. So chromium gives a lot of different bright colors in different oxidation states in its solutions. Okay, so we have both. Remember, copper 2+ gives us a deep blue solution. In solution, with water, it gives us deep blue solution. Chromium +6. Chromium +6, by the way, gives us yellow, intense yellow color solution. I will show you pictures from Google, and you can even Google it out yourself. Chromium +6 gives us intense yellow solution. Okay, so we have 2 transition metals which give us completely different colors separately. Now, but in this compound, they are combined together. You know, what color do you get when you combine blue with yellow? What color do you get when you combine blue with yellow? You get green. You get green, right? So therefore, in this picture, which is given in your book, you see that the solution at the bottom of this U tube is green in color because it has both copper and chromium +6. Copper 2, chromate 6. Blue and yellow are mixed here. Now, because of these different electrostatic charges on these electrodes, this is positively charged because connected to the positive terminal. This is negatively charged because connected to the negative terminal. The cations will be attracted according to their charges. Now, copper 2+ is a positively charged ion. It's a cation, so it will be attracted towards the cathode. And chromate, remember I'm talking about chromate, CrO4 2-, because it's an anion, it will be attracted towards the anode, and therefore we have this deep yellow solution here. So this is really beautiful. You can see green at the bottom, then we have blue near the cathode and yellow near the anode. So this is like sort of a proof of the fact that this substance is breaking down into its components due to the passage of electricity through it. Okay, this is an example. So that was that. Let me share a picture of this with you that I found in Google. Let me share it. Okay. Yes. I have a bunch of questions. We will, after we have finished the whole course, we will do questions, as many questions as we can. Okay, look at this. This is the picture I found. See how beautiful it looks. So there's this bright green at the bottom with blue near the cathode and yellow near the anode. This is another diagram I got. Okay, same thing, showing the same thing. So copper ions are going towards the cathode and chromate is going near the anode. Okay, now let's move on to the industrial electrolysis of aluminum. By the way, I don't think I need to explain this lead bromide experiment to you guys, which is explained on page 107. Page 107, this lead bromide, I have already discussed this with you. We have figured out its anode and cathode reactions. This page. I don't think I need to explain this to you, right? This is simple. Okay, they're just explaining the apparatus that they have used, but basically it is the same phenomenon. So yeah, it is easy. Yeah, so we have done this. Okay, so now let's move on to the industrial electrolysis of aluminum. Whose video should we see? Why? Who is sharing videos? Let me see. You have to keep your eyes on the host's video, by the way. I cannot make out who else is showing video. I cannot see anybody else's video. Okay, anyway, so you keep your eyes on the host's video. Okay, so now there's nothing complicated about this. This is easy. Okay, this is easy. This is molten aluminum oxide. Why aluminum oxide? Because aluminum oxide, and aluminum oxide, is the form in which aluminum is found in nature. By the way, its ore is called bauxite. Bauxite. Here they have mentioned bauxite. This is the spelling. Okay, so after purification and everything, what we are left behind with is aluminum oxide in the form of Al2O3. Al2O3. Why do we get Al2O3? I hope everybody knows this. Because aluminum has a charge of +3 and oxide has a charge of -2. So we crisscross. So Al2O3. That's why we have the formula Al2O3. Now its melting point is really high, but we need to melt it if we want to extract aluminum. So we add an impurity, which is sodium cryolite. Sodium cryolite. By the way, the formula for sodium cryolite is this. This is the formula for cryolite that we add in molten aluminum oxide. Why? In order to decrease the melting point. I hope you remember how the impurities decrease and increase the melting points, and how they affect the melting points. So we decrease the melting point so that we have to use less energy in order to melt it. Okay, and once it is molten into its liquid form, then the ions are free to move, okay, towards their oppositely charged electrode. And see how cleverly they have arranged the electrodes. They have lined the container, this whole tank or whatever this is, they have lined it by cathode. Why? Because they wanted the aluminum, because aluminum is a metal. Okay. First of all, let's write down its overall reaction. Okay, let's write down its cathode and anode reactions and its overall reactions, and then we will discuss the apparatus. So we have this ionic compound. We have this ionic compound in the liquid form. We have melted it. Okay, we will ignore the cryolite. By the way, the process is not this simple. There are other ions as well, which make this whole process complicated, but we will not deal with it. Okay, so keep life simple for yourself. Aluminum oxide will break down into its components. The components are aluminum and oxygen. Aluminum exists, it is a metal. It exists as a solid metal. So I will write this down. I know oxygen is a gas. It's a diatomic gas. So I will write this and in the gaseous state. Okay. Now there are two atoms. So in order to balance, I will put a 2 coefficient next to aluminum. And oh, this is not that easy. Wait. So this is 3. Now 3 and then this is 2. So 2 3s are 6 and 3 2s are 6. So I can do that. 3 2s are 6 and then 2 3s are 6. So I got this wrong. Now this is 2 2s are 4. So 4 aluminum. Right? So the balanced equation is this. Okay, 2 aluminum oxide, 4 aluminum and 3 oxygen. Okay. Now cathode reaction. Cathode reaction would be aluminum cations, right? So this is cation 3 plus accepting electrons. We will figure out how many electrons later. Aluminum solid. Okay. So am I getting wrong here? Okay, let me see. I'm doing it with pencil so that I can erase. Okay. Now this is cathode reaction. Then this is anode reaction. Anode reaction would be oxide. Okay. Releasing oxygen and electrons. This is loss of electrons. So this should be 2 because there are 2 here. So 2 2s are -4 here. And then this should be 4 as well. So 4 but this is 3. Okay. And here is 4. So what do I do? Can I do this? Let's balance this. Okay. I'm just trying to balance this out. Let's see. So for aluminum, let's see. Maybe I'm wrong. Let me see. They haven't been balanced, by the way, in your book. Maybe I'm wrong. I don't know. You guys also try to balance it. Okay. Let's do it together. You guys also try it. 3 2s are 6 and this should be 3 4s are 12 electrons. What? Time. Are we out of time? Okay. Okay. So the overall reaction is this. Did you understand how I did this? Okay. Why should I check from Google? Inshallah, we'll do it together. Okay, so this is my overall reaction. Did you see how I did this? This was a little complicated though. So aluminum ion was gaining 3 electrons to get deposited as aluminum solid, and then oxide into oxygen. Okay, there were 2 minus here, and okay, so I balanced it out. So I had -4 here, so I added 4 electrons here. Now I have 3 electrons and 4 electrons here. So I do not have the equal number of electrons. So I multiplied this whole equation by 3. Okay, so that I get equal number of electrons. That would be 12 electrons. 4 3s are 12 and 3 4s are 12. Then I So this is multiplication. After multiplication, 4 aluminum ions, 12 electrons, and this should be 4. Sorry, this should be 4. Okay, in the form of solid. Okay, this is 6 oxide. See how I multiplied 3 to the 6 oxide. Okay, gave me 3 oxygen, 3 molecules of oxygen, and 12 electrons. So now I have equal number of electrons. I cancelled electrons and I, okay, so 4 aluminum, 6 oxide, and then aluminum, okay, 4 aluminum and 3 oxygen molecules. Okay, ma'am, the way you do it is longer. Okay, if you know an easier way, okay, if you know the easier way, please share with me. Okay, and then now real quick, I will discuss this apparatus because we are out of time. So this lining is attached to a cathode. Why? So that, because you know, these are the two products, right? Aluminum and oxygen. These are the two products. So by this equation, I know the two products are aluminum and oxygen. Okay, aluminum is a metal, molten, so it will sink to the bottom because it is denser. And oxygen, it's a gas. Gases are less dense, so it will rise at the surface. So considering those properties, they have lined the container by the cathode so that the aluminum gets attracted towards, and it is easier for the metal to sink, and so that it can be easily tapped out. Okay, whereas the anode is in the form of these sort of electrodes sinking at the surface of the electrolyte, so that when the lesser dense gas rises upwards, it can be easily collected or can be disposed of into the environment. Oxygen is not a harmful gas, so it's okay. Okay, so that's that. And yeah, so but still, despite adding cryolite, the temperature is pretty high, 1000 degrees Celsius. You have to bring the temperature to 1000 degrees Celsius. So just imagine what the temperature would be if we do not add cryolite. So cryolite is very important. Okay, then inshallah, in the next class, we will discuss the electrolysis of solutions. Now I will take your questions real quick. Whoever is getting late for anything is free to leave. I am done with explanation. If you have any questions, then you ask questions. Okay. Okay. Arham, please, can you please show me, tell me what your easier, shorter way is? Arham, I want to know. Can you please share your easier, shorter way with us? Yes, I have unmuted you.
I just, well, I count the ones like for what first I do is I find out what are balanced and what are not balanced. Once I find out what is not balanced, in my mind, I write the equation and then I try to put numbers in it. Once I see if all of them are balanced, then I put the numbers into the equation.
You know what, the way you are telling me, you are saving time, but there are chances of going wrong. And in the exam, you cannot afford to do that, right? You'll lose marks. So it is better, even though it might be longer, it is better to go the systematic way so that you do not miss out on anything. Now, you saw that this aluminum oxide equation was pretty tricky, you know? While I was solving it, I thought I was going the wrong way. But then, alhamdulillah, I managed it. So the thing is that if you go, you know, this is your beginning stage. So at this stage, I would recommend that you go the proper way, the systematic way. Then when you have gotten the hang of it, when you are an expert in it, then you can, you know, opt for your shortcuts. Okay?
I just tried it so many times that I mostly get it all the time because I practiced it in 7. So.
Okay, good job. Good job.
Yeah, that's why it didn't seem that hard for me in grade 8.
Okay. Okay. Okay, then I will give you, you know, equations to balance in the future. Okay, Arham, I'll remember this. It's okay. Teacher, will we have classes every day? Okay. It depends upon you guys. If you want classes every day, you want days off, please let me know in the group. Let me know in the group. It all depends upon you because you see, these classes are absolutely voluntary. So I'm not a part of a school. I don't have to follow any schedule. So I'm really flexible. So if you guys want to take any day off, you guys decide amongst yourself and then let me know in the group. Okay? Yes, Syed Nabil, you want to say something? Yes?
Yes, is aluminum oxide reaction is a decomposition reaction?
Aluminum, yes, it is. Yes, it is.
Okay.
Yes, how come? Because aluminum oxide is a compound and then it is breaking down into aluminum and oxygen. And I just told you that electrolysis causes decomposition of the electrolytes. Okay, electrolysis causes decomposition of the electrolytes. Okay, will it be chemistry class tomorrow? Don't you want rest? That's a good question. Okay, tomorrow I was thinking we do transport in animals, but it's totally up to you. Okay, you guys can let me know what you want. Okay, in the group. Yes, I do take rest. I took rest over the weekend. Okay, you guys, do you read before you attend my class? Tell me, do you guys read the book before attending my class and or after attending my class? Do you read the book on your own, or you just come attend and then go and that's it, end of the story? Huh? Sometimes before, sometimes. No, not sometimes. It should be regular. Okay, if you do not read the book before and after the class, then you know these classes won't help you that much. Okay, so if you want these classes to be helpful and useful, you gotta read before and after. Okay? Yes. Okay, good job, Ibrahim. I'm glad that you understand whatever I teach you. So tomorrow, inshallah, we will do transport in animals, and we will be discussing, we will start with the treatment. Remember, we were at the treatment of coronary heart disease. Okay, Amna, you want to say something? Yes? Okay. Okay, is there any other question? Okay, Jazakallahu khairan for the compliments. Jazakallahu khairan for the compliments. Okay. Just, I would like it a lot if you guys read before and after the class. It would be really useful for you. And
Hey, I want to ask this question.
Yes.
How does oxygen decides that if when it reacts with carbon, it forms carbon monoxide or carbon dioxide?
Good job. Good job. I like that question. Yes, that's a very important question. I forgot it. Totally. Good job. See, this is what happens when you read the book beforehand. So if I forget any point, you can remind me. So I like it that way. Okay, now what decides if the product of carbon and oxygen reaction would be carbon dioxide or carbon monoxide? Now, I'm sharing my video. Okay, this is the last question and then I will end. Now we have carbon and we have oxygen. Sometimes we get carbon dioxide and at other times we get carbon monoxide. Okay. Now, you know, here there are 2 oxygen atoms bonded to 1 carbon atom, and here only 1 oxygen atom is bonded to carbon atom. This shows that you need more oxygen. You need more oxygen for this compared to this. Okay, compared to this. You need more oxygen for this as compared to this. So when you have plenty of oxygen, when this is in excess, or if the question says plenty of oxygen, or they use some adjective that reveals that oxygen is plenty, okay, you have enough oxygen, then you will have enough oxygen, like 2 oxygen atoms per carbon atom, so you will get carbon dioxide. This is called complete combustion. Complete combustion means all the carbon has reacted with oxygen to give you carbon dioxide. Okay, this is complete combustion. Now, when you have limited supply of oxygen, meaning that you do not have enough oxygen to have 2 oxygen atom per carbon. So only one oxygen is available per carbon atom, so you get carbon monoxide. So it depends upon how much oxygen is available. When you have excess of oxygen, plenty of oxygen, you will get complete combustion, carbon dioxide. If the oxygen is limited, that's when you get incomplete combustion, okay? So incomplete combustion means that a poisonous gas, carbon monoxide, will be produced. Complete combustion means that carbon dioxide, which is completely harmless gas, will be produced, okay? That is why incomplete combustion is not good. It is not good. When you know, you have seen smokes coming out of old vehicles, especially in Karachi and Pakistan, when you have, you know, बहुत सारा धुआं निकला होता है पीछे से. Why? Because there is not enough oxygen for burning with carbon, and so carbon monoxide, which is a harmful gas, is released. Okay, so and then if you have even less oxygen, sometimes carbon cannot react at all with any oxygen, and then you have black carbon, which is called ash. You know, they're like simple carbon. It did not get any oxygen to combine with, and so it just burns. I mean it just gets distorted in its structure, but nothing, I mean, it does not bind with, it does not form any bond with any oxygen. Okay, so that was the answer to your question. Okay, then any other question? Should I end the meeting now? Any other question? Yes, Amna, one more question. Okay, yes.
Yeah, but there is like O2, right, and 1C. So why doesn't it just directly react to get CO2? Why does it react with other carbons to get carbon monoxide?
Well, that's a very interesting question. Let me think about it, and then you also Google it, or you know, read books or whatever source you might have, and I will also look for it. But I currently don't know the answer to this. Yeah, that's a very good question. That why does oxygen go on and combine with other carbon, and why can't, you know? Yeah, I don't know. Maybe I have no idea. I have to look on it. Okay, I have to look for the answer. Okay. Okay, now I'm ending the meeting. Jazakallahu khairan. Okay. Assalamu alaikum wa rahmatullahi wa barakatuh.
Walaikum salam.
Walaikum salam wa rahmatullahi wa barakatuh.
Allah Hafiz, miss.
Allah Hafiz.
Allah Hafiz. Allah Hafiz. Allah Hafiz.
I am